13. So first go.
Guys, just stay in the meet. We will be starting the session in just 8 minutes. So just stay in the meet. Yeah. So we will be starting the session. And I think Ibrahim has not yet joined. Okay. So meanwhile, I think he will join in between. So today we will be discussing about a few important things. So that's why I think this is your first lab session, right? So actually this lab session is a little bit longer. So that's why we divided it into two parts. So this is the part one of first lab session. And again tomorrow is also a lab session. It's a part two. So both come under the lab one. So today we will be telling you
Okay.
few things, and tomorrow you will be doing some simulation using LT Spice. Okay, you'll be doing some simulation and generating graphs and how to simulate a circuit. So all these things we will be discussing in tomorrow's session. So today we will be discussing a few things like about one filter circuit, okay, which we will be gonna simulate the same thing tomorrow. Okay, and I'll also be giving some assignment to you all today, a small activity, and you can also work on it. Yeah. So I'm sharing my screen. So actually, I just want to ask one basic question. Let me see who will be answering the question. So you all know about single layer PCB, double layer PCB, and multi-layered PCB, right? So can someone just tell me ESP32, okay, which is a famous module. So it is made up of how many layers? Is it a double layered PCB or triple layered? So any idea? Anyone? You have been using ESP32 since long, right? Everyone. So you might have used it for IoT projects and lots of things.
Four layer piece.
Yeah, it's a four layered PCB. So what about Arduino Uno? Any idea? So ESP32 is four layered PCB. What about Arduino Uno?
Two layer.
Yeah, correct. But ESP32 is four layered PCB. The reason is that see in Arduino we'll be having only two layers, top layer and the bottom layer. But whereas in ESP32 we'll be having four layers. Along with the top layer and the bottom layer, in between these top and bottom layers, again two more layers will be there. So basically, ESP32 itself is a complicated thing than Arduino Uno. So it involves ESP involves some wireless communication and all this stuff, right? So that's why it is made up of four layers. I hope you are able to hear me, right? Let me check. Yeah. See, actually, there is something like I'll show you. NCP 1117. Okay, NCP 1117, which is an IC. Basically, LDO, low dropout voltage IC. So you can see NCP 1117, low dropout voltage regulator, LDO regulator. So can you just tell me few applications or few modules where you can find this NCP 1117 IC? NCP 1117 IC. It is actually a famous low dropout voltage IC. It's a voltage regulator. Any idea? Where can you find this NCP 1117 IC? Like, uh, you know, Arduino or I mean Arduino Uno, or you can just tell me if you have any idea. Actually, this NCP 1117 IC is found in Arduino Uno as well as Pi Zero, Raspberry Pi Zero. So you know about Raspberry Pi Zero, right? So you might have used famous board Raspberry Pi Zero. So we are having in Raspberries, we are having so many modules like Pi Zero, Pi Zero W, right? So many Pi 2, Pi 3, Pi 4, 0 to W. So like that. So actually this NCP 1117 is found in um, you know Arduino module as well as it is found in some Raspberry modules. So this is actually an important point. So many people forget that it is found in Arduino Uno, but Raspberry is little bit advanced, so that it may not be there in Raspberry. Yes, it's a partially correct as well as it's a partially incorrect as well. So because this NCP 1117 IC is not found in all Raspberry modules. So it is actually found in Pi 1, okay, Pi 1B, B plus, and 0, 0W. So I repeat, pi 1b and b plus 0, 0w. In these 4 modules, you can find NCP 1117 IC. Okay. But what is the difference in NCP 1117 IC that you find in Raspberry Pi B or B plus or 0 or 0W module with the Arduino Uno? Any idea? Anyone? Anirudh, do you have any idea? So this NCP 1117 IC is found in around 4 Raspberry modules, 4 variants of Raspberry modules like Pi 1B, B plus 0 and 0W. And it is also found in Arduino Uno as well. So what's the difference in the NCP 1117 IC that you find in Raspberry modules and the Arduino Uno? Yeah, so I'll tell you because I know you might not be aware of this thing. So actually in NCP 1117 IC we are having 2 main variants. Okay, like we are having different voltages. So if you just go through the parts of the Arduino Uno, okay, if you just go to the schematics of the Arduino Uno module, so you can find that schematics in the online as well. If you just search for Arduino Uno R3 schematics, there you can find. So in Arduino Uno, basically NCP 1117 5.0 is used. Okay, where the voltage, output voltage VO or else V out would be equal to 5.0. That means 5 volt. But if you just in case of Pi 0 module, Raspberry Pi 0 module, again you can find NCP 1117 IC, but it is the output volt. It is designed for the output voltage of 3.3 volt. Okay, here you can see. So this NCP 1117 IC is found. There are different. It is available in different output voltages, like starting from 1.5 volt, 1.8, 1.9. 2.0, 2.5, 2.85, 3.35, 12. Yeah. So fixed output voltage. So let's assume that if you take NCP 1117 5.0, the output voltage would always be equal to 5.0. Okay, fixed stable output voltage. If you take NCP 1117 3.3 volt, then the output voltage would be 3.3 volt only. So in Pi 0, you can find 3.3 volt. Whereas in NCP 1117 in Arduino Uno, it uses NCP 1117 5.0, where the output voltage is 5 volt. Okay. So in Pi 1B, B plus 0 and 0W, we can find NCP 1117 3.3. That means where the output voltage of the IC would be 3.3 volt. But coming to the Arduino Uno, the output voltage, the fixed output voltage is 5 volt. Okay. So what about the other Raspberry modules like Pi 2, Pi 3, Pi 4? So I only told about Pi 1B and Pi 1B plus 0 and 0W. Pi 0 and Pi 0W. So what about the rest of the Raspberry modules like Pi 2, Pi 3, Pi 4 and 2W? Okay. If you just take Raspberry Pi 0W, in that you can find NCP 1117 IC which is having the fixed output voltage 3.3 volt. But if you just take Pi 0 2W, then you can find the same NCP you do not find any kind of NCP 1117 IC. Okay. So they are using some other voltage regulator. Okay. So why I am telling all this thing? Because see, here I am having a simple schematic where I try to clone some kind of Raspberry Pi CM4 module. Okay. See, if you want to clone any kind of Raspberry module, first you need to know what are the voltage regulators, which variant of Raspberry module is using which voltage regulator, why we need to use that voltage regulator only, why not the other. So all these kind of parameters you need to take into consideration. Unless you are very clear about the voltage regulators which are used across various Raspberry modules, then you may not be able to you will be seeing some schematic online and you will be doing cloning, but you are not completely aware what's happening internally. Okay, so that's why you just need to know. So the assignment that is the first activity that I'm giving you. So just make a list of all the different variants of Raspberry modules, and you need to prepare a table. So first serial number and the second column the name of the Raspberry module or variant, like is it Pi 1B, B plus 0, 0W, Pi 2, Pi 3, Pi 4, 0 2W, 3B plus 4B, and like that, Pi 5. So just make a table, and what kind of voltage regulator technology is being used. So is it max lean? There is Raspberry modules uses other voltage regulators also, like MXL max linears 7704, and which is actually power management IC. Okay, we will discuss in very in detail about. We will be having a separate lab session maybe in the upcoming week, where we will be discussing about all these things in the upcoming lab session. So as of now, what you need to understand is that in NCP 1117, the NCP 1117 IC is actually a low dropout voltage regulator, which is used in few Raspberry variants of Raspberry modules and also used in Arduino Uno. And coming to the difference between them, so what you found in Raspberry modules, which is having the fixed output voltage of 3.3 volt, and the same NCP 1117 IC which is there in Arduino Uno, it produces a fixed output voltage of 5 volt. Okay, and coming to another thing, I also told one more thing, like MXL 7704. I'll show you that. MXL 7704. So actually this MXL 7704 is also called as PMIC. Okay, it is also referred as PMIC. So what is the full form of PMIC? Anyone? What is the full form of a PMIC? These are actually very simple basic terminology which is used in PCB designing. Okay, this is actually very basic terminology what I'm just telling you. So PMIC means power management integrated circuit. Power management. PM means power management. Are you following me? Hello. Everyone.
Yes, we are with you.
Yeah. So PMIC means power management IC. See what I told earlier, like NCP 1117 IC. NCP 1117 IC is not actually a power management IC. It is not actually a power management IC. But coming to MXL 7704, this is power management IC. Okay, complete power management. So now can someone just tell me which is having more features? Is it PMIC, power management IC, MXL 7704 PMIC, or NCP 1117 IC? So what do you think, which IC will be having more functionalities and capabilities? So I will ask let me go with Teja Anirudh. So can you just unmute yourself? Teja Anirudh.
Yes, sir.
Yeah. So between NCP 1117 IC and MXL 7704 PMIC, so what do you think, which one is having more number of capabilities and features? No idea? Nihal Reddy, any idea? Nihal? Sri Krishna, any idea? It's a basic question. I just don't know why you are not able to answer the question. MXL 7740. It's actually 04. Okay, that's fine. At least you predicted the correct one. It's MXL 7704. It is also known as PMIC, Power Management Integrated Circuit. Okay. So what is the difference between NCP 1117 IC and MXL 7704? So this is NCP 1117 IC. The document, this is the data sheet of, and let me just also open some documentation or data sheet for the other one. Yeah, max linear. So now all what I need is like, what is the basic difference between these two ICs? See, this is used in few of the Raspberry modules and this is also used in few of the Raspberry modules. So then what is the difference between these two things? That's very essential to understand. See, the NCP 1117 IC can produce only one output. Okay, this can produce only one output, and MXL 7704 IC can produce 5 outputs. Okay, is that clear? This is the first point. The number of outputs produced by NCP 1117 IC is only one. You cannot produce more than one output from NCP 1117 IC. But coming to MXL 7704, it is a power management IC, complete power management. It is having capabilities of entire power management. Okay, so that's why it is producing 5 outputs. Yeah. So now we are discussing about two different things. One is NCP 1117 IC and as well as MXL 7704. We are discussing between differentiation between two different ICs. So this is actually very essential to understand, because if you know this, then only you will be able to clone any kind of Raspberry module. Okay, I'm not even going in that much of detail right now. Okay, so at least you need to have a basic overview. So we are discussing about NCP 1117 LDO, low dropout voltage IC, integrated circuit. Okay. Yeah, and then the next one is MXL 7704, which is actually nothing but one kind of power management integrated circuit. So here the prefix MXL indicates max linear. Okay, it is a prefix max linear. MXL means max linear. So now the number of outputs which are produced. Okay, we need to discuss the number of outputs produced by the first one and the second one. So coming to this one, it produces outputs. Yeah, how many? Anyone? Only one. Only one output. Okay, and the second point is, this is the first point, and second point is neta. Okay, neta means efficiency, because if whenever you are building any kind of no matter you are working on PCB design or integrated circuit design, VLSI technology, or else you are working on floor planning of IC making, so everywhere efficiency plays an important role. So efficiency is one of the key parameter. Okay, so coming to the efficiency, it would be something like around 50 to 70%. 50 to 70%. You can expect around 50 to 70% of efficiency. Okay, and what is the maximum current it can, that you can obtain from this is up to 1 amp. You can obtain up to 1 amp of current. And this is most important point, it is not programmable. It is not programmable. You cannot program this IC. Few ICs can be programmable and few ICs are not programmable. Okay, this IC is not programmable. We will discuss in detail what about this programmable and not programmable as well. And so where you can find this NCP 1117 IC? In Arduino Uno R3 or whatever, maybe in Arduino Uno you will be you can find it, as well as in few of Raspberry modules also can find it, like like pi 1, pi 1b, b plus, and you can find it in 0 and 0w. So in these Raspberry modules, you can find this kind of low dropout voltage IC. So how you need to reconfirm whatever I am saying, just go through the schematics of those modules. There you can, then you can identify this particular IC is actually present in a schematic. Okay. So but the thing is, like in Arduino, you know what you will be finding is NCP 1117 hyphen 5.0. Okay, that means it's a 5 volt, you know, the output voltage is fixed, 5 volt output. But whereas in these kind of Raspberry modules, you can find the same. For example, if you take pi 0, if you take a pi 0 into consideration, then you can find NCP 1117 IC, but the voltage is hyphen 3.3. See, this is the naming convention. This is the IC name, and this is the voltage produced, output voltage produced by the IC. Okay, this is the naming convention. Wherever you can find this hyphen followed by some integer. So no matter if voltage is indicated or not, usually voltage is also indicated, but sometimes mostly people also neglect the voltage symbol. Then you can identify that this IC this is a variant of the IC which is designed, specifically designed to produce the output of 5 voltage. Okay, yeah. So these are the important points. So now we will check, we will do the comparison with Max Linear 7704. So we need to understand what is the efficiency and all these parameters again. Okay, so I'm beginning with my first point, number of outputs. Number of outputs, how many? It would be 5. So total it will be producing 5 outputs. So again in this 5 there are 2 categories. Okay, 4 comes under one category and the one output comes under another category. So again I will explain you what are those 4 outputs and what is the remaining one output, that we will discuss. Okay, so the next point is like efficiency. Again, efficiency. So what is the expected efficiency if we use MXL 7704 IC? It would be around 90 to 95%. Okay, it would be around 90 to 95%, which is really more efficient than the NCP 1117 IC. So that's why some people prefer MXL 7704 over the NCP 1117 IC. Okay, so this is the efficiency percentage. So if you want, after completion, after I mention all points, you can take a screenshot, or else I will post in the group as well. So yeah, now what are the actually in MXL 7704 IC we can obtain different currents. Okay, you can obtain different currents like 1.5 amp, and we will discuss about that. Okay, again a little bit later, or else yeah. So total I told there are 5 outputs, right? So from that 5 outputs you can obtain 1.5 amp, 1.5 amp, 2.5 amp and 4 amp, around 4 amp plus sometimes. Yeah, so these are the current, okay, output currents. So now we need to discuss one more thing. This is most important point. This is actually programmable. Okay, it is programmable. And how can you program it? So using I2C protocol. Using I2C protocol you can, or I2C. Okay, using I2C or I2C protocol you can program this. Okay, this is important point, programmable. This is programmable. Okay, how will you be programming it? With the help of I2C protocol. We discussed about that there exists some protocols, right, through which a microcontroller can communicate with its slaves. So it can communicate with I2C protocol. So these are the important things. So up to here everything is clear, right? Are you able to follow, everyone? Yeah, so it's not a rocket science, it's a very easy to understand. So where we are just differentiating between 2 different ICs. So both are used in Raspberry module, so then what's the difference between them? Okay, So I'm not going very much in detail, just to give you an overall idea, so that you need to do self exploration so that you can understand much better. Yeah. So give me a second. So okay, again in this 5 outputs, it is actually classified into 2 different types. Okay, it is classified into 2 different types. I just don't know where I can find an arrow symbol here in paint. Yeah, so I have drawn it manually. I just don't know where I can find an arrow. Maybe this is of different variant. Okay. Acha, got it. So in these 5 outputs, there are 2 different variants. Okay. So the first 4 comes under buck converter. Okay. First 4 comes under buck converter category. Yeah. So the first 4 comes under which category? Buck converter category. Okay. And the remaining one comes under LDO category. First 4 comes under buck converter. And the next 4 comes under LDO, low dropout voltage category. And the next 4 comes under LDO, low dropout voltage category. Sorry, next remaining one comes under LDO. So now tell me, see, if you just observe both of these things, this NCP 1117 IC is just one voltage, one low dropout voltage regulator. But this MXL 7704 is internally having one low dropout voltage. Okay. So basically, along with LDO, now it is having 4 buck converters also. It is having 4 buck converters. Now tell me which is preferred. See, this IC is having low dropout voltage regulator as well as 4 buck converters as well. Okay, but in NCP 1117 IC, it's just only a low dropout voltage regulator. This PMIC, power management IC, comes with both buck converters and low dropout voltage regulators. Both things are included in PMIC. Yeah, of course, there would be a variation in price. Maybe this PMIC would be little bit having higher price, and this NCP 1117 IC may be available at lower price, cheaper. Okay, but that is the basic difference. So I hope this is clear, right? Shall I move to the next concept? Shall I move to the next concept, everyone? Today we will be taking an additional hour due to the lab session. So yeah, shall I move, everyone? Abdul, is it fine? Are you able to follow? Abdul Hafiz. Ibrahim, are you there? Ibrahim. Ayub, Ibrahim. Yeah. Let me save this. Yeah. So this is the basic difference between both these ICs. Now we will jump into the next concept. Okay. So this is very complex for you to understand. Okay. It would be very complex for you to understand. So basically in KiCAD we will be creating one project. Okay. So where to in the next lab session you need to do simulations. I will just give you a overview, and tomorrow in the tomorrow session I will do the simulation, and once I am done with the simulation I will ask everyone randomly. So you need to share your screen and you need to do the simulation. You need to obtain one graph. Okay, we will be simulating a one kind of circuit which is actually called as 20 notch filter. 20 notch filter. 20 notch filter. How many of you know about this 20 notch filter? See, this is a circuit diagram of 20 notch filter. Okay, this is a circuit diagram of 20 notch filter. So how many of you aware about this particular 20 notch filter? Any idea? Anyone? Or is this the first time that you are hearing the term 20 notch filter? శ్రీహరి ఒక హెల్ప్ చేయ అర్జెంట్. ఇక్కడ ఈ పేజెస్ ఉన్నాయి కదా, అన్ని ఫోటో తీసి నాకు పంపాలి అర్జెంటుగా ఇప్పుడే వాట్సాప్లో నా నెంబర్కి. నీట్గా కనపడాలి నాకు అక్షరాలు. ఫ్రంట్ బ్యాక్ చూపిస్తాయి ఇటు. అడదిప్పు అక్కడి నుంచి నీకు ఇచ్చిన దగ్గర నుంచి మొత్తం ఇక అన్నీ అంతే. Yeah, so see, if you just check the circuit diagram you will come to understand why it is called as 20 notch filter. So see, this is one kind of T structure and this is the another T structure. So there are two T structures, right? So basically this is like alpha, character T, letter T in the alphabet. So in the English alphabet this is like T and this is like another T. So basically two T's are there. So that's why this is called as 20 notch filter. So basically now you understood why it is called 20, right? These two are twins. This is one T and this is another T. Total two T's are there. So that's why it is called as 20. Later we will discuss, once you do the simulation of this particular circuit you will be obtaining one kind of graph. Okay, you will be getting one graph. In that graph there would be a notch structure, notch. So that's why this is called as 20 notch filter. So basically we will be filtering some input. Here you will be providing some input, some signal, input signal, could be some sinusoidal wave, AC sweep. We will be doing some AC sweep analysis and DC sweep analysis. So here we will be providing some sinusoidal wave and you will be obtaining some output. Are you able to follow? Are you able to see my screen, everyone? Yeah, thanks for confirming. So you will be providing some sinusoidal signal input and you will be obtaining some output. Okay, over here you will be getting some output and you can also pass that output signal through a load resistor. Here RLs means it's not actually a resistor. Okay, so many people think that whenever there is something like RL in a circuit diagram they think that we need to put some resistor. So how many of you still thinking like that? RL means we need to put a resistor. So I know many of you. See, right, isn't it? So but actually RL indicates a load. Okay, load means you are connecting something like a fan or maybe any kind of electrical equipment, okay, or else any kind of electronic device or electric equipment. So basically any device, if it's connected to the output voltage, we usually indicate it with RL because every device will have some resistance, right? So we simply denote with RL, load resistance. So this is actually one kind of filtration circuit. So how many of you remember that I told you in the introductory sessions of ECEDA, I told you that in every circuit diagram there would be so many protection mechanisms involved, right? So how many of you remember that? Protectory circuits. Can you just name a few of such protections? Anyone? Sri Krishna, can you just unmute yourself?
Heat sink.
Yeah. So can you just tell me, or can you just name some of the protection components which are used in PCB to protect the circuit and the entire mechanism? Guys, I request everyone, can you please be active during the session? So
Pull up
if you, yeah,
resistor,
yes, Sri Krishna.
a pull up and pull down resistor.
Give me a second. Yeah, can you just repeat again?
Pull up and pull down resistor.
Pull up and pull down resistor. It's not actually part of protection mechanism, not completely part of protection mechanism. So you can name something like ESD, electrostatic discharge diodes, ESD diodes, electrostatic discharge protection diodes, and some decoupling capacitors, bulk decoupling capacitors, and we'll be using something like opto isolators, right? And we'll be using some fuse and metal oxide varistors, metal oxide varistors. Yeah, so all these components are used for protection mechanism, right? So there are some standard protection circuits, okay, some standard protection circuits. So see, to give any input to any kind of module or any kind of sensor or any electronic device, so you should not blindly expect that whatever the signal that you are getting is yeah, TVS diode. Yeah, right. Yeah, correct, Ibrahim. Perfect. It's a good example. TVS diodes are also used. So whenever you are giving any kind of signal input to any kind of electronic device or electrical device, so you should not blindly assume that always I get a cleaner signal waveform. Okay. Any input signal is always prone to noise. Any signal is usually prone to noise. For example, can someone just tell me what is the frequency of the electrical current that we are receiving from the substations and power stations all the way to our homes? What is the frequency of the alternating current in India?
50 hertz.
It's a 50 hertz. Perfect. Maybe if you just go to some other country like USA, America, there maybe they're something like a 60 hertz they may be using, right? So in different nations, the frequency of the alternating current which we are receiving from the substations or from the transformers all the way to our home, so it differs from nation to nation. In India it's 50 hertz. And also remember one thing, so let's assume that you are the manufacturer of some kind of electronic device, and you made it in such a way that all the components and the entire circuitry mechanism inside that supports only 50 hertz. Okay, but the same equipment, maybe someone powered it from USA. Okay, so now the frequency is different. So now do you think the electronic device or electrical device will it run perfectly, or will it get damaged? Obviously it will get damaged, right? Because the entire circuit mechanism that you designed, the entire schematics, the entire components that you have selected, chosen, all supports 50 hertz. Okay, because you manufactured in such a way. But the electronic device actually expects 50 hertz, which is the operational frequency. But the supplied frequency, the input supplied frequency is some other frequency. So obviously it will damage. So then what you need to do? You need to eliminate certain frequencies. Sometimes you need to, sometimes in certain circumstances, you need to eliminate some frequencies. Okay. So this is whatever the circuit diagram that I'm showing you right now. Okay. Give me a second. Yeah, whatever the circuit diagram that you are seeing on the screen right now, this is actually one kind of filtration circuit. Okay, one kind of filtration circuit. And why this filter is used? Because to eliminate, to reject certain frequencies in the input signal. So let's assume that this input frequency, input wave, the signal wave, it could be some sinusoidal wave of some frequency. Okay, some, let's say any frequency, but it is not a pure signal. It is also having some mix of noise. Okay, and you know what is that noise frequency. Okay, and you want to eliminate that frequency. So once this signal passes through this entire mechanism, this entire circuitry, so by the time it reaches the V out, okay, it will be something like a pure, I mean, whatever the wave that you want to eliminate it, whatever the frequency that you want to reject from the input signal, so that frequency will not be there, it is absent in the output voltage. Okay, this can be how you can analyze this particular thing. You need to do, first you need to make the schematic in the KiCAD, and then you need to do some, you need to see, whenever you are placing the components, don't directly place these components from the standard libraries. Okay, because standard libraries do not support simulation. So in KiCAD there is a special library like P-splice. Okay, so P-splice, where P means PCB. So in P-splice library, you can find, or else you can use, there is also some simulator library. So from that simulator library, you can obtain these components like capacitor, resistor, and see, you can find one component over here, right? This is actually one operational amplifier. This is an operational amplifier. Yeah, I just don't know whether you are following me or not. Everyone following me, right? You are able to understand, right? Yeah, perfect. See, actually, whatever that I'm telling you, that, yeah, someone trying to join the meet again still. Prakash Verma, you are late. Yeah. So let me just come back to the same circuit diagram again. See, first I will show you the output waveform of this. I just, let me show you, give me a second, I will reshare my screen again. Okay, I'll just reshare my screen, give me a second. Output waveform of 20 notch filter. See, actually you need to do the simulation also. Okay, in the upcoming lab session I will make you to do the simulation also. So this is actually very important. This is one kind of protection mechanism. You can eliminate some frequencies. So if you see the graph, then you will be able to understand much better. Okay, just give me a second, the page is loading. Yeah, I'm sharing my screen. See, also we'll be having one quiz. Okay, exciting quiz very soon. Maybe tomorrow or day after tomorrow, I don't know. Our team will post a message in the group. You can follow the updates. Yeah, I hope you are able to see my screen, right? Can just quickly confirm with thumbs so that I will proceed with graph. Perfect, perfect. So let me close the existing tabs and let me jump into yeah. See, actually this is a very important graph. So when you do the simulation in the everyone able to see my screen, right? Just a quick confirmation I will, because if you don't see my screen it would be very difficult for you to understand. Everyone can just quickly, yeah. So as you can see, this is the expected output. Okay, when you perform the simulation for the circuit diagram that I have shown you, so this is the expected output. You need to get similar waveform. Then only it means that whatever the circuit diagram that you did and the simulation, everything went perfect. See, if you just observe this schematic, if you observe this graphical representation of the output waveform, here you can find one V kind of structure, right? V structure. See, V like structure. This particular structure we actually call as notch. Okay, in English, in terminology, so usually we call this particular structure, it's like a notch structure. We are having a notch over here. So that's why in the schematics, if you just check the schematic diagram, see, this is actually called as bandwidth. Okay, the gap between these thing is actually called as bandwidth. So sometimes bandwidth may be little bit larger and sometimes bandwidth may be little bit longer. That means you will get the same notch, but the notch will be very narrow. Okay, so this particular band, okay, frequency band, it would be little bit narrow in certain cases. It depends upon the values that you are choosing for the resistor and capacitors. In the circuit diagram, based on the values that you choose for R and C, sometimes the band gap may be bandwidth may be little bit long, and sometimes you may get a narrow version. But ultimately this should be an ideal waveform. Okay, first it should get decremented over here and you will be getting a notch and again incremented. So what does it mean? So see, if you just observe this waveform, so this particular frequency is there, right? So this is actually called as central frequency. So this particular frequency is called as central frequency. As you can check over here, this is 50 hertz frequency. So here 50 hertz frequency is the central frequency. Okay, so now what actually he's trying to do is he's trying to eliminate some frequency, right? So this particular frequency you want to eliminate from the input signal. So that's why at here you got, see, in the output waveform at 50 hertz, what is the voltage? What is the voltage? See, on x-axis you are having frequency, and on the y-axis you are having voltage, output voltage, V out. Okay, so this is the frequency. Okay, and this is the voltage. So if you just put a probe, or if you take help of any kind of CRO, oscilloscope, then you can analyze all these information. So this particular graph is between output frequency and the output voltage. Okay, so in input waveform, in input sinusoidal waveform, there is no notch over here. So it is like something like it's going something like this, and maybe somewhere else it may take a bend like this, and again it may go, about how sine wave look like, right? So but here in the input waveform there is no notch over this region, but at the output waveform you have got a notch. So that's why this particular filter, okay, what we are discussing right now, it is called as twin T notch filter, because it is having two T shapes in the upper, in the upper part, and in the lower part it is having two T shapes. So that's why it is called as twin T and 20 notch filter, because in the graphical representation you will be getting a notch. So that's why it is called as 20 notch filter. So why filter? So filter means something which removes unnecessary thing. Okay, you will be having something which is having some noise or impurity or unnecessary component. So you need to remove that unnecessary component. Here we need to remove the unnecessary frequency. Okay, what is the unnecessary thing here? Unnecessary frequency. You just don't want that frequency to be present in the output voltage. So it is doing some filtration. So that's why this is called as it's one kind of filtration circuit. I hope everyone is clear about output graph, right? Expected waveform. Everyone, can you react with thumbs? So you are clear about why it is called as 20, why it is called as a notch filter, why it is a filter. So it produces a notch in the graph. If you want to eliminate some or eliminate some frequency from the input voltage, you want certain frequency not to be present in the output voltage, output signal waveform. So then you can take help of a 20 notch filter. It is one of the widely used filter, among one of the reputed filters. Okay, it is widely used. Yeah. So now we will jump into the next concept. Okay, so everyone can pay attention so that you can understand much better. Yeah. So now we will be discussing what we discussed about why it's a naming convention, why it is called as 20 notch filter. Now we need to discuss what values we need to take for resistors and capacitors, isn't it? Unless you know that, it's very difficult for you to understand. Yeah. So we are having few more theoretical points about this 20 notch filter. We will complete that and we will jump. Okay. So we will post some handwritten notes as well if possible. See, this circuit is also called as BSF or BEF. BSF or BEF, where E means elimination. See, actually in the original schematic, these two terminals are connected with each other. Okay, in the original schematic, these two terminals are connected with each other. And from these two terminals, like somewhere else in between, you can take the output voltage. This is the input voltage and here you need to take the output voltage. See, I will show you the original schematic. So now, can someone let me see? Can anyone able to answer? See, this is the original schematic. So I will do one thing. I will hit my screen. Okay. So I'm just splitting my screen. Yeah. So now just observe two different circuits. Okay. Observe both circuits. So now what here you can see these two terminals are connected with each other, and here these two terminals are not connected in the handwritten notes. Okay. So here in the right side circuit diagram, from this connection, like you have taken one junction or some node, and from here, from the junction of these two terminals, LP out and HP out. Okay, I'll tell you what does LP mean and what does HP mean. Okay, and so from the junction formed between LP out and HP out, actual output voltage is output signal is taken. Okay, but here in the representation I have segregated two different things. Why? Because See, actually this upper part is called as low pass filter. Okay, upper part is called as low pass filter, and the bottom part over here is actually called as high pass filter. Okay, we discussed that there are two T structures, right? So the one T structure is the low pass filter and another T structure is the high pass filter. So one is low pass and another one is high pass. Whatever the output that you are getting from the low pass filter, it is called as LP out. Okay, low pass. See, it's just a naming convention. You just no need to think very deeply. Okay, it's just a naming convention. So you are providing some input. Okay, some input waveform, some AC voltage. So this voltage is common for both high pass filter and low pass filter, because see, here you will be providing the input voltage. It travels over here and it goes through this particular circuit and goes down, and it will also passes through the eventually it passes through either both of these filters. Okay, so upper part is called as low pass filter and bottom part here is called as high pass filter. So actually this low pass filter is one kind of filtration mechanism, and high pass filter is another filtration mechanism. So basically what we are doing is we are connecting these low pass filter and high pass filter in parallel with each other, which forms the twin T notch filter. Is this point clear, everyone? Clear, right? So basically see, low pass filter is another individual filtration mechanism. It is also used in few of the circuit schematics. Okay, it is also used in few of the electronics. And high pass filter is another kind of filtration circuit. So what we are doing in 20 notch filter is that we are taking one low pass filter and we are taking one high pass filter, and we are connecting these low pass filter and high pass filter in parallel with each other, and from the junction which is, or from the node which is formed between the output terminal of the high pass filter and the output terminal of the low pass filter, from that we are obtaining a single output. Okay, which we are calling it as simply the output, which is actually the output of the 20 notch filter. Okay, later again if you want to amplify this signal, you can pass this output voltage to any amplifier, unit gain amplifier, like you can take any amplifier. Here in the circuit diagram we have taken something like where is this circuit diagram? Okay, I think I have split the screen, right? Yeah. So here see, it is also indicated that you can take either LM741, here LM prefix is not indicated, LM741 or LM351, which is one kind of operational amplifier. Whatever the signal output waveform which you are getting from here, see, this is the, see, again one more important thing. Now can someone tell me this upper part, is it low pass filter or high pass filter? Let me see who will answer this question. Yes, Sri Krishna.
High pass filter.
This is high pass or low pass?
High pass.
High pass filter, perfect. So this one is low pass filter. See, actually we while I am, while our team is writing on in the preparing the handwritten notes, they have drawn in a different way, but both are equivalent. Okay, except this particular connection. Okay, except this particular connection, both are equivalent. I will tell you why I have not connected this HP out and LP out in the first schematic that is showing in the handwritten notes. So how to identify whether if among these two T's, how to identify if it is a high pass filter or low pass filter? See, in high pass filter there would be CRC. Okay, two capacitors and one resistor. If you find two capacitors and one resistor, then it is a high pass filter. If you find two resistors and one capacitor, it is a low pass filter. See, here we are having, this is the R1 resistor 1 and this is the R2 resistor 2, and we are having a single capacitor. So RCR network, resistor, capacitor, resistor, two resistors and one capacitor. So this particular network, here you can find resistor and capacitor. So this RCR block is nothing but low pass filter. If you find CRC block, two capacitors and one resistor, okay, CRC block, here you can find CRC block, then it is a high pass filter. So this is the high pass filter and this is the low pass filter. And see, here I have shown in a one kind, just a block diagram. You are applying some input. See, this is not a schematic diagram, just a block diagram to help you to understand much better, visualize much better. See, this is the terminal where you can apply the input voltage, any kind of sinusoidal waveform which is containing some noise, a known frequency. Okay, and see, this is the low pass filter, which is nothing but RCR block. Okay, RCR block, this bottom one. Here you can find RCR. Okay, so this is the low pass filter and this is the high pass filter, CRC block. See how these both blocks are aligned with each other, how these two blocks are connected with each other. Are they in series connection or are they in parallel connection? So let me ask someone, Ibrahim, yeah. So are they in series or parallel with each other? Relative to each other, are they series or parallel? In 20 notch filter, we are having one low pass filter and one high pass filter. These low pass and high pass filters, are they in series or parallel? It's in parallel. Okay, so now can someone, anyone, everyone can just raise your hand, those who want to support Ibrahim's answer. So Ibrahim is saying that both are in parallel. So everyone who supports Ibrahim's answer can raise your hands. If you want, I will show you the thing again. Okay, this is the block diagram. This is the low pass filter. This is the high pass filter. Are they in series or parallel? Very simple question. I'm not going very in detail in electronics, right? If I go in very in detail, you will literally, it will blast your brain. Prakash Verma, you need to respond. Either it should be whether you are supporting Ibrahim's answer or not. Prakash Verma, are you there? Yeah. So Ibrahim's answer is correct. It is very simple question. You know about, you have solved the equivalent capacitance, equivalent resistance, isn't it? In your lower standards. So you can easily identify if they are in series or parallel. So these both low pass filter and high pass filter are in parallel with each other. So this is the output waveform. See, this output waveform itself is deficient of noise, or it is not containing the specific frequency that you are trying to eliminate. Okay, let's say you want to eliminate something like 1 kilohertz of frequency or some noise. Okay, and to do that, see, all you need to do is like you need to select these RCR values, like what is the value for resistance and capacitance. All these things you need to decide. Okay, based on them, these things would vary. Okay, basically the output waveform which is obtained from the junction of both these low pass filter and high pass filter output terminals, there whatever the frequency that you are trying to eliminate or reject, okay, that is not there. Okay, that will be discarded, that will be not there in the output waveform. Again, you are passing that signal to an amplifier. This amplifier amplifies the signal, and from the amplifier you are getting the output waveform. Okay, this is the basic block diagram representation of the 20 what is that, notch filter. Yeah, so this is an example model graph, but the actual graph would not look like this. Okay, but the actual graph would not look like this. Here you will get some notch like a V shape. Okay, and where we have already discussed that this particular frequency where this notch meets the x-axis, the horizontal axis, the that particular thing we call it as the central frequency. Okay, where I have shown you the graph, right, where 50 hertz of frequency is the central frequency in that particular scenario. So this is the model graph. Actual graph, practically it would be different. Like you will not get a sharp like this. You will get something like it is decreasing over the time and again increasing over the time. Okay, and see, you want to pass this particular, see, you want to eliminate, you want to reject frequencies from f1 to f2. So initially in the input waveform you are having you are giving some signal, right, that contains frequencies of f1 and f2 as well. I mean it is also having some signal waveform, it's not empty in F1 to F2, but in the output waveform you want to eliminate this particular area, you want to eliminate this particular signal. Okay, so the from F1 to F2. So this is the model output waveform after passing through this entire filtration circuit. If you take the output from here, this is the model graph, but practically the graph would be little bit different, which I have shown you earlier. So among these, the first part is called as the pass band. Okay, this is the pass band, and here SB means stop band. S means stop, P means pass, S means stop. Pass band, stop band, pass band. So I'll show you the same graph again, the practical graph. See, this is the pass band. This is also the pass band, but this particular area, okay, this particular area, this is actually stop band. That means you want to stop these frequencies from. See, already here you can see at 50 hertz of frequency, the value of voltage, output voltage is 0. Okay, as soon, see, if you want to eliminate 50 hertz of frequency completely in the output waveform, and you have chosen the values of resistors and capacitors in such a way that in the output waveform 50 hertz frequency is rejected. Okay, so now if you check the graph also, the output, the voltage at the 50 hertz of frequency, this is the central frequency. Okay, at that frequency the output voltage is 0. So as how you can say, so gradually as you are approaching 50 hertz of frequency, so gradually the voltage decreases. So when it reaches the 50 hertz frequency, it becomes 0, output voltage becomes 0. Is that clear, everyone? Let me go back to Meet. Everyone, is that clear? Graphical representation, that is the expected output waveform. All you need to simulate that actual waveform in the KiCAD. So this is the first lab experimentation. Everyone clear? So in the next few minutes, I'll be taking questions from you. After taking questions, I want some stupid questions from you. And after answering the questions, we'll have a 5 minutes question and answer session. And then we will jump into the next part. It is not done yet. I'm not done yet. Still, we are having a little more theory. And so tonight, everyone should be ready with the schematic. By tonight, everyone should be ready with your schematic. Tomorrow, I will tell you, I will make my own schematic and I will do a small simulation, and you need to directly run your simulations. Everyone need to show your output waveform, and then the lab is done. It is not actually part of KiCAD curriculum, okay? This is the first thing I want to make you clear. It is not at all a part of the KiCAD course, but I just want to tell you something interesting. Rather than just doing simulation for resistor and capacitor, because you might have done these output waveform graphs for capacitor and all this stuff in your, maybe in your engineering or even in lower standard. So I just don't want to repeat the same simple circuitry. I want to tell you something a little bit complicated, or which is useful practically in making PCBs. See, these filters are widely used everywhere, you can find that. So that's why it's a very essential to understand. Yeah, so now it's a question answer session, so you can unmute yourself and you can ask questions. Now it's time for you. Okay, yeah. Yeah, anyone can, you can just start asking questions so that I can answer the questions.
Can you explain how should we simulate the graph?
Can you explain?
How should we simulate the graph?
How should we simulate the graph? See, simulating the graph is not part of the today's class, because all the concepts may not be covered in a single session. As I told earlier in the beginning, this lab is a little bit lengthy. Okay, so that's why we segregated into 2 parts. This is the first part of the first lab session. Tomorrow would be, or day after tomorrow, our team will inform. That would be the second part of the lab session. So as of now, what I'm just trying to make you understand is like, what are filters? So this low pass filter, high pass filter, and what is the output waveform that we need to obtain. So I will show you the simulation in the next session. So what, as of now, what you need to do is like, you need to go through the schematics that I've shown you for 20 notch filter, and try to make a own of your own. Okay, try to clone the schematic in the KiCAD. I hope everyone has already installed the KiCAD in your systems. What I just expect in the upcoming class is like you all I expect that all you guys are ready with your schematic clone. Okay, that's the main objective of the today's session. Simulation will be performed, but that is not, everything cannot be completed in a single session, because for simulation again I need to explain so many things, so many libraries, so much history is there. Okay, yeah. Any more questions? No more questions. Great. So that means you all understood very well, or you are not asking questions because you haven't understood anything. Everyone, can you again quickly please react with the thumbs emojis so that I can proceed? I will get some energy to proceed further. Ibrahim, everything is clear, or are you stuck at somewhere else in the session? Ibrahim, Nihal Reddy, everything fine? Are you able to follow Nihal? Ibrahim, are you there? Ibrahim. And who else is there in the meet? Prakash Verma. You are not responding, Prakash Verma. Yeah. Without delay, let me move further because there is a lot to tell you. See, now no one asked me question why you have not connected these two terminals over in the first schematic diagram. So I expected at least you will be asking this question. So here both terminals are connected. Why you have not connected these two terminals? So the reason is like it is actually, see, we are not only just simulate. See, I already told you these two filter circuits are individual filtration circuits. Okay. Actually, this low pass filter is one kind of filtration circuit, high pass is another kind of filtration circuit. So now first what we'll be doing is, with the help of probe, in KiCAD there would be some probe option. Okay. So with the help of probe, by placing your probe over here, first we will be analyzing the output waveform of the low pass filter. Okay, and then we will be analyzing the output waveform of the high pass filter. See, if you just connect these two terminals, it will become, see, then if you just connect these two terminals, what happens? This low pass filter and high pass filter will be parallel with each other. If both these are parallel with each other, then it will become 20 notch filter. Okay, but first what we need to do, we need to analyze the output waveform of the low pass filter. First we need to analyze the input waveform, and then the output of the low pass filter, and the output waveform of the high pass filter. Then what happens if we connect these two terminals and obtain an output terminal, and if we just analyze the output waveform of the 20 notch filter. So total we need to analyze the input signal waveform and the input signal waveform and the low pass filter waveform and high pass filter circuit output waveform, and then the final output waveform when these low pass filter and high pass filter are parallel with each other, which basically forms nothing but 20 notch filter. So total waveform 1, waveform 2, waveform 3, and coming to this circuit diagram, here we need to analyze the output waveform. Total 4 waveforms we need to analyze. Is that clear? Well, that's why I have not connected over there, because first initially we need to analyze that particular schematic, then we will be joining the two terminals, then we need to analyze the final output waveform when both the both the functional blocks, I mean filtration blocks, are parallel with each other. So this is the basic thing. Okay. See, and if in case tomorrow there is no lab session, tomorrow we will be discussing about UUID. Okay, UUID. Have you ever anyone heard the term UUID ever before? UUID. I'm posting in the chat box. you might wonder, all these things are part of PCB designing, isn't it? Aren't we discussing something? We are not discussing the rocketry, all the things. These are all are part of electronics. Okay, it's a huge field. The more you start exploring deeper, it's a ocean of knowledge. The more you explore, the more you will come to know. So even sky is also not your limit. You can go beyond the sky. You can go deep into the cosmos, universe, ever expanding. No end limit. The more you explore, the more things you will come to know. So basically, maybe in the tomorrow session, if there's no lab, uh, we will be discussing about UUID, which is very important concept. So in KiCAD, okay. So shall I proceed further, everyone? See, now there is one small formula, simple formula. Okay, how to determine the notch frequency? So what is notch frequency? Anyone, what is notch frequency? Just unmute yourself. I'm not coming back to Google Meet again. Someone or Sri Krishna, you can unmute. So what do you mean by notch frequency? Any idea?
The frequency at which knot is created in the graph, like the V shape.
Yeah. So basically we want to eliminate some frequency, right? Which we are referring it as the unwanted frequency. So to determine that unwanted frequency which will be eliminated in the output waveform, okay, even though it is present in the input waveform, that particular frequency we call it as the notch frequency. To determine the notch frequency, the formula is subset n is equal to 1 by 4 pi RC, where R is the resistance and C is the capacitance, and you know the pi value 3.14, right? You can substitute the values, or 22 by 7. So Fn is equal to 1 by 4 pi RC. Okay, this is a formula to determine the notch frequency. And so again, see, coming back to below schematic diagram, so different people usually represent these resistors and capacitors with different representations or designators. Okay, so some people usually write these resistor as 2R, 2R and 2C. Coming to the, when you just come to the something like RCR block. So you know about RCR block, right? RCR. So it is low pass filter. Okay, RCR block is, see, just remember in a simple way, if you find two capacitors, it is high pass filter. If two capacitors are there, it is high pass filter. If only single capacitor, it is low pass filter. So in the RCR block, you can find, see, this is written as 2R, this is written as 2R, this is written as 2C. So coming back to the, this is story about low pass filter. Now coming back to the high pass filter. So this is C only. Okay, this is C only. This is also C. This is R. So from this, what you need to understand is that whatever the values of resistor and capacitor, okay, whatever the resistance and capacitance that you choose in the low pass filter, usually they are double the or else in other words we can say whatever the values of capacitor and resistor that you choose for the high pass filter, okay, and they are usually half of the low pass filter, or else the values of the low pass filter, the values of resistor and capacitor present in the RCR block of a low pass filter, they are double the values of the actual values that you have taken for high pass filter. Is that clear, everyone? Is that clear? Yeah, this is very important. Okay, so I will show you with the actual schematic also. There also you can correlate this particular thing with that one. Okay, see, observe this schematic. What happened? This is the high pass filter. So I told you that whatever the values that you take in high pass filter, so if you just compare that with the low pass filter, the value of the low pass filter, the values of a capacitor and resistor or components present in the low pass filter, they are double the values that you have chosen for the high pass filter. See, here it is C and C, but here it is 2C. Here it is R by 2, here it is R, that means 2 times of R by 2. So the naming convention would be different. Some people see, if you can also indicate this particular thing as something like C by 2. You can indicate this as C by 2, you can indicate this as C by 2, this as R by 2, this as R, this as R, this as C. If you indicate these two capacitors as a C by 2, then here you need to indicate as C. If you indicate as C and C over here, you need to indicate as 2C. Is that clear? I think someone is having a question. Yeah. Yes, Sri Krishna. Looks like you are having some question. Yeah.
We have two capacitors in series, right? Why can't we have different values of capacitors? Like one can 1C and another will be 2C.
Can you come again? Why can't we have?
Two capacitors of different values rather than having similar values.
Why can't we have two capacitors of different values?
Yes.
See, this is actually some standard circuit. Okay. So if you go deeper, there is a huge thing that you need to know. Okay. So this is a standard circuit, standard schematic. If you want to eliminate some frequency, so you need to follow that convention. You need to follow that practice. So there is a mathematical derivation why you need to choose that as well. So if time permits, maybe in the upcoming session, I may present few slides. I'm not going that much in detail. So basically, as of now, you need to understand that it was decided in such a way. If you choose those values, then at the if you just check the output frequency, output waveform, output signal, whatever the frequency that you want to reject, that can be rejected, that can be eliminated in the output waveform. Okay. Yeah. So we can also derive some mathematical expressions. So, but I just don't want to because here what we need to focus is like how we can make these kind of circuits in, how can we do simulations in KiCAD. So that is the main objective. So yeah. So I just don't want to deviate from the actual curriculum. So that's why I'm just giving you an overall brief. See, this is also one kind of representation. So this is also one kind of, just like we have shown the block diagram, right? This is the schematic representation. Okay, schematic representation. See, you are providing some input waveform over here, this particular terminal, and you are obtaining some output waveform over here, and this is an input sinusoidal wave. It also contains some noise, or else you want to eliminate some frequency over this particular region, and when it passes through the filtration circuit, at the output waveform you will getting a notch over here. Okay, so that's why it is called as a notch filter. So this is a schematic representation. Yeah, I'm going to KiCAD. I'm going to KiCAD. Let me check if live stream is going on or not. Yeah, perfect. It's been 1 hour 30 minutes. Okay, no problem. So I'm in KiCAD. Okay, I'm just going to file new project, Control plus N, and I'm going with the default. Click on OK. I'm going with the default. Click on OK. It should show a dialog to give a project name. Yeah. So let me create this project in somewhere else, like yeah, inside projects. So I'm giving the name 20. You can give in lowercase 20. Yeah, that would fine. or else you can give a full name 20 hyphen notch hyphen filter. For simplicity, I have given 20. So I'm going to the schema. I'm going to the PCB document. First, let me go to the schematic, because first we need to do the schematic and circuit diagram. Then we can jump into the PCB design. So here PCB design is not the main objective. So the main objective of this lab session is to introduce you the simulations. Okay, there are so many circuits that can be simulated. We are not going in all the circuits. If we are having some list of thousands of widely used circuits, we are not going through all the circuit diagram. Usually for each and every batch we randomly choose one circuit diagram among those hundreds and thousands of circuits, and we explain that, okay, to how to perform simulation. So this time for you we have chosen 20. Okay, and so now I'm going to the place. I'm going to place. Give me a second. Yeah, I'm back. Yeah, here in the KiCAD. So now I'm going to the place option. Click on place symbol. Okay. See, actually we will be using something called as spice library. Okay, spice. So what is the full form of spice? Anyone? What is the full form of spice? So spice means simulation program with IC. E means, I think, emphasis, I think so. Let me check. Spice full form. No. Spice PCB, or else a simulation full form in simulation. Yeah, emphasis, I'm correct. So spice means simulation program with integrated circuit, IC emphasis. Okay, so this is the full form of spice. So this spice library is used to do simulations for the circuit diagram. Okay, you can do some simulations. So let's discuss about three core components of spice library. Okay, so there are three core components of spice library. Okay, I'm actually I ran out of memory, so I'll just explain orally. Okay, so there are three core components in spice library. The first one is passive modules. Okay, first one is passive modules, and the second one is active devices, and third one is sub circuits. Okay, there are total three main components in spice library. So what is the full form of spice? Spice means simulation program with IC emphasis. Again, I'm not expanding IC, integrated circuit, because you know that, right? IC emphasis. This is the full form of SPICE library. SPICE. So there are three main components in SPICE library. So the first one is active components, and second one is or else we can put passive first. Passive components, and we have active components. We are having passive and we are having active, and we are also having something like subcircuits. These are the three main components in the SPICE library. So what comes under active components? Some examples. Okay, in active components we can find, or else you do one thing, you do research. Okay, let me not reveal everything, you just do research. I will give examples for subcircuits. Okay, so in subcircuits you can find op amps, operational amplifiers, and some power filter, and we can find some power filters.
Yes,
See, for example, let's take the case of 20 notch filter. Okay, for example, let's take something like a, or else you can take high pass filters, low pass filters, or operational amplifiers. All these, for example, let's take one op amp. Okay, one operational amplifier. So can someone just tell me one example for an operational amplifier? LM? Anyone? What is the operational amplifier we have seen in the schematic diagram? LM741. Okay, this is one kind of operational amplifier. Okay, this is one kind of op amp, operational amplifier. You can take something like a single gain amplifiers. So all these comes under subcircuits. So active and passive are basic things, so I'm not explaining. You must already have a prerequisite knowledge about this. If you don't know, just search for examples for active and passive components. So these three main components are available in SPICE library. Okay, so whenever, see, if you want to do some simulation, if you want to do some simulation, pick components from PSpice library. From which library? From PSpice library. Okay, you need to choose the components from PSpice library. See, actually in SPICE also, to be more specific, in SPICE also we are having so many different SPICE. I'll show you, I'll explain. Actually I skipped that part as the session is becoming more lengthy. See, even in SPICE also you can find different types. For example, LT SPICE, which is widely used. Okay, LT SPICE, it is actually widely used for simulating for analog circuits. Widely used for analog circuits. And then we are also having HSpice. This HSpice is used for, HSpice is actually, this is HSpice is designed by Synopsys company. Okay, Synopsys, and this is used in IC design. We are having a separate course on IC design and VLSI. There you will come to know about this thing. Okay, and the next library is PSP. Like this, so many are there. PSpice. Okay, yeah, PSpice. And this PSpice library, this is also included in KiCAD. Okay, this is actually included in KiCAD library manager. Okay, or else let me check if it's possible to bring them back. Yeah. So it is included in KiCAD library. So it is actually part of standard system libraries in KiCAD. Okay, standard system libraries. Okay. So now we will be using PSpice library. If you want to do some simulation, you have to pick the components from PSpice library. Yeah. So these are the important things. So SPICE means simulation program with IC emphasis. We are having different things like LT SPICE, which is widely used for simulating analog circuits, H SPICE, which is designed by Synopsys, which is used in IC simulations in IC design in integrated circuits, and PSpice, it is included in KiCAD standard system libraries, where P means PCB. Okay, you can assume like that. And there are three main components. Okay, three main different kinds of components that you can find in SPICE library or PSpice library: passive components, active components, and subcircuits. For subcircuits, op amps, power filters, operational amplifier, example LM741, all these come under subcircuits. So if you want to do some simulation, pick components from PSpice library, or else you can pick it from simulation underscore SPICE library. Simulation underscore SPICE library also. You can pick from these libraries. So these are the basic things. Before you do the simulation, these are the basic things you need to understand. So everyone clear, right? Is that clear? Concept. Everyone, please react with thumbs, then I can proceed further. Yeah. So now I'm in KiCAD. I'm going to schematic file. So here you just simply type PSpice. Or else type for SPICE. So you got simulation SPICE library, right? See, all these are part of simulation underscore SPICE. That's what I told you. You can place the components from simulation underscore SPICE library. So for example, if I want to place some resistor, you can that will be present in this particular list. You can place a resistor. See if yeah, or else first let's place something like operational amplifier LM 741. Okay, amplifier operational. So double click on it, and here you can place it. Okay. So you can go to the properties also. Double click on it, you will get properties. So here you can find simulation model. Okay. So see, if any component is not mapped with any simulation model, you need to download the simulation model from the online. Okay. So you need to click on the simulation model, and you need to upload the .lib file or .sub file. .sub means .subcircuit, or else .ibs files. You can pick it from the file explorer. Okay, I already have one simulation model file with me. Okay, you can choose that file simulation model, and you can click on OK. So automatically that simulation model will be assigned to this particular component. Okay, so all you guys as of now do one thing, just complete the schematics. Okay, I will provide you the links for the simulation models maybe in the WhatsApp group when I am free. Okay, we will do the simulation, we will make the schematics, and we will do the simulation in the next lab session. So up to here, I hope the session is informative, right? Today's session, everything clear, right? So we discussed so many interesting things, that ESP32 is made up of a 4-layer Arduino Uno, 2-layer top layer and the bottom layer, and we discussed you know the ICs. Okay, two different ICs. So one is one is NCP 1117 IC, which is a low dropout voltage regulator, and another one is MXL 7704, which is PMIC, power management IC. And we had a glimpse of a differentiation between them, in a tabular form. Number of outputs in NCP 1117 is 1, MXL 7704, total 5 outputs, among 4 are buck converters, 1 is LDO. We have also determined the efficiency. So in NCP 1107 it is 50 to 70, and in max linear it is 90 to 95%. And we discussed that MXL 7704 is programmable, whereas NCP 1117 is not programmable, and where these ICs are present, and two variants in NCP 1117 like hyphen 3.3 and hyphen 5 volt 5.0 volt. And then we discussed about then we discussed about the filtration circuits, what is 20 notch filter, why it is called as 20, why it is called as notch. We have analyzed the graphical representation, and I have shown you the block diagram, and how to choose these capacitor resistor values, like one is double of the other. And so one is low pass filter, high pass filter, both are connected in parallel with each other. And the graphical, what is the expected output graph, and block diagram representation, and the schematic representation. And we discussed the formula to determine the notch frequency, or the frequency of the unwanted, or else the unwanted frequency that we want to eliminate, the notch frequency, how to determine. We discussed about bandwidth. Okay, yeah. So in the next session we will be discussing a few more useful things, so amazing things, so stay tuned. So hope today's session is very informative for you all, and this is your expert mentor Hemant from Suchana. And just a second, so this course is powered by Suchana Space Expo or Suchana Space India, and I am your expert mentor Hemant, and co-presented by Grow IOTA LLP, which is headquartered in Chennai, Tamil Nadu. And our special partners, Ergal Technologies, Anu Electronics from Chennai, and Luna Energy, your all-in-one EV solution for electronic vehicles, and Green Energy solution. So thank you for being a part of our Suchana family. Hope your journey with Suchana is amazing till today, from your day zero. And since you started, many of you started with ECDA course, so we taught you so many things, chemistry behind them, so many things we discussed. So today we are ended with discussing the advanced concepts, like one of the most advanced concepts like filtration circuits, in which we discussed about 20 notch filter. So thanks for being a part of our Suchana family, and we request you everyone. So you know about our trust pilot, right? Everyone, Sri Krishna and other Ibrahim, everyone. So we request you everyone, kindly please post your feedback, a positive response on the trust pilot. Just leave a review and send this link to everyone, and let them post feedback or leave a review about Suchana in the trust pilot. And we request everyone to kindly please just circulate this thing, that how we are teaching these sessions, the useful sessions, making technology, electronics accessible to rural areas. So at Suchana, our aim is to make this technology and knowledge accessible at every corners of the globe, to make it accessible and useful across the globe. So we have put a target to inspire more than 1 million students in the upcoming years. So kindly please make this initiative move forward. So we request everyone to kindly please circulate this information with your friends, family members, your relatives, any students that you know who are interested to join into the Suchana courses, so that all the people will get benefited from whatever the content that we are providing, our online curriculum. And very soon we will be starting physical classes in Chennai, in the areas of Chennai, Hyderabad, Secunderabad, and many more areas. So you can during that time we'll send an announcement in our official WhatsApp community, which is Meta verified. So there you can find the information. Already few of the sessions have already been started in the Vitt Vellore, near Vitt Vellore, and soon more information will be provided in the official community. So those who are interested, you can as of now at international scope we are not conducting the physical sessions. Probably we'll also start that very soon. So we are trying to streamline everything. We are trying to expand our community and expand our services to across the globe. And so this Suchana initiative is more than a classroom. It's more than an education institute. So we are put a target to transform millions of lives, to make technology accessible, education accessible to every corner of rural areas. So we request everyone, can you please cooperate with our initiative and make this initiative move forward. And thanks for everyone for being a part of Suchana family. This is your expert mentor Hemant from Suchana signing off. Bye, take care. So in the next few minutes I'll be taking questions from you, then we can wrap up the today's session. Yeah. So if you have any questions, you can ask. Unmute and you can ask. Nihal, you have any questions? Ibrahim, Prakash Verma.
No, sir.
Yeah. Ibrahim, you have any questions? You can post yes or no in chat box so that I can wrap up the session. No questions. So you want today's session recording or not? You need today's session, right? But actually for lab sessions, we are not supposed to post the recording link. So those who attended the lab session, they can only watch it. Those who have not attended, we cannot provide or else it's actually we should not record the lab session. Okay, I will anyhow I will try to communicate with the admin team, and we'll try to post the lab session recording, as it will be useful for you for the later revision as well. So also you can, yeah. So I request everyone, kindly please, I am posting the link where you can leave your feedback. Okay, those who have not yet provided the feedback, or you can ask your friends, everyone, to post their feedback in the Trustpilot community. I mean, in the Trustpilot platform. I'm posting the URL in the chat box as well. So everyone, can you please leave a review in the Trustpilot? Make sure that at least you make sure that everyone can join, at least one or two students, so that everyone will get benefited from our teachings and our sessions. Okay, I've posted the link in the chat box for the Trustpilot website where you can leave a review. Okay, you can go through this particular website. Okay, and in the here you can find. So while posting the feedback, make sure that you are not completely posting from AI, because if you just copy paste from any AI response, it will be automatically rejected by the system. They are having some scrutinization process. So you can post the genuine review. Okay, so thank you for joining today's session, lab session of KiCAD, and this is your expert mentor Hemant from Suchana. Bye, take care, see you in the next session.